The next section is on graphing and solving quadratic inequalities. So just a few reminders about inequalities. We are always going to rewrite them as a y equals in order to graph. Remember that less thans and greater thans use dotted lines. Less than or equal and greater than or equal use solid lines. And then with inequalities, you always pick a point and see whether you should shade where that point is or on the other side of the line. The only difference is that since these are quadratics, they're no longer going to be lines, but they're going to be parabolas. So they will either be a dotted parabola or a solid parabola. And we want our equation to read, again, basically y equals. So this first equation, 2x squared minus x, is greater than 3 plus y. Well, if I solve that so that y is alone, I would subtract the 3. So I would have 2x squared minus x minus 3 is greater than y. So if this entire expression is greater than y, and I want my y to be first, that means y would have to be less than the expression 2x squared minus x minus 3. Now, graphing this inequality in standard form, so the vertex will be the x value, the opposite of b. So the opposite of a negative 1 is a positive 1 over 2a, so 2 times 2. That gives me 1/4 for the x value. Then when I substitute that in, I get 2 times 1/4 squared minus 1/4 minus 3. That is 2 times 1/16 minus 1/4 minus 3, which that reduces to 1/8 minus 1/4 minus 3. So I'm going to change this one to eighths. 4 times 2 is 8, so 1 times 2 is 2. So 1/8 minus 2/8 is negative 1/8 minus 3 is negative 3 and 1/8. So it is 1/4 negative 3 and 1/8. 1/4 negative 3 and 1/8 would be about right there. And that's where I'm going to make my new crosshairs. And then I'm going to do my XY table. So 0, and it's basically x squared, and then 2y. So 0, 0, 1, 1, 2, 2, 4, 8. So there's my 0, 0. And I want 1, 1. And symmetrically, 2, 8, or excuse me, it's 1, 2. So 1, 2, and symmetrically 2, 8, and symmetrically 2, and this shows me it is a dotted parabola. So it's either going to be shaded inside the parabola or outside the parabola. I'm going to pick the point 0, 0. So I put 0 here and in these two spots. I get 0 is less than negative 3. No, it is not. So I shade outside the parabola. because 0, 0 is inside, and that was no shading. Okay, let's try these two inequalities. This time I'm going to do this first one in green, and it's in vertex form, so the green one's vertex is -1, -6, and that's where I'm going to put my new crosshairs. And again, my XY table, and it's 2y, so 0, 0, 1, 1, and 2, 4. So there's my 0, 0, 1, 2, and symmetrically 2, 4, 6, 7, 8, and symmetrically. And this one shows a dotted line again. And it looks like I can pick 0, 0. It's inside that parabola. So if I put 0 here and here, I get 0 is greater than 2 times 0 plus 1 squared minus 6. That 0 is greater than 2 times 1 squared minus 6. That's 2 times 1 minus 6. That 0 is greater than -4. And yes, it is. So far, I'm inside this parabola. I'll do the next one in black. And that is an intercept form. So I have an intercept here of x equals 3. So that is 3, 0. And x equals -1. That is -1, 0. So when I plot 3, 0 and -1, 0, I am there. So my vertex would be halfway between those. So 1, 2, 3, 3 plus -1 divided by 2 is 2 divided by 2 is 1. So the x-coordinate is 1. And I substitute y in there. I get y as a -1 minus 3 times 1 plus 1. That's y is a -1 times -2 times 2. That's -4 times a negative is +4. So I get a vertex on the black one of 1, 4. So then, when I do my XY table, 1, 0, 0, 1, 1, 2, 4, and then I get a -1y, so 0, -1, -4. So here is my 0, 0, 1, -1, and symmetrically 2, -4, and symmetrically. And this one is a solid parabola. Let me just fix that. And again, I see this 0, 0 is inside that parabola. So if I put that in here, I get 0 is less than or equal to a negative times 0 minus 3 times 0 plus 1. 0 is less than or equal to a negative times a negative 3 times a 1. Negative negative is positive. 3. 0 is less than or equal to 3. And yes, it is. So I'm also inside the black parabola. So I end up being inside both parabolas, which would be just this part. So I'm going to erase these lines. I'm going to skip that one. All right, let's try these two parabolas. Again, I'll do the first one in green. So it is in standard form. So my vertex, opposite of b, which is 0, divide 2 times negative 1. 0 divided negative 2 is 0. And when I put 0 in there, I get 0 plus 9 is 9. 0, 9. And when I make my XY table, and I have a negative 1, 0, 0, 1, 1, 2, 4. I get 0, negative 1, negative 4. So 1, negative 1, symmetrically. 2, negative 4, symmetrically. An equal bar, so it is a solid parabola. Again, I see 0, 0 inside that parabola, so I'm going to put 0 in those two places. And I get 0 is less than or equal to a negative 0 squared plus 9, which is 9. 0 is less than or equal to 9, and yes, it is. So I'm inside this parabola. Do the second one in black. This time it's standard form again. So the opposite of b would be a negative 4 over 2 times a is 1. Negative 4 divide 2 is negative 2. When I substitute that back in, y equals a negative 2 squared plus 4 times a negative 2 minus 6. That is 4 minus 8 minus 6. That is negative 10. So I get negative 2, negative 10. Negative 8, negative 10. Right there. And I'm just going to add, I'm just going to use this. So 0, 0, 1, 1, and symmetrically, and 2, 4, oh, I think I'm off a spot here. Let's graph that one again. I think I'm off a spot. 1, 2. So 2, negative 10. And then I have my 1, 1. And symmetrically. And 2, 2, 3, 4. There we go. And this one shows another solid parabola. So again, I see 0, 0 inside there, so I'll put my zeros in here. And I get 0 is greater than or equal to 0 plus 0 minus 6. 0 is greater than or equal to negative 6. So it is not. So I'm inside, or yes, this is true. I'm inside both parabolas again. So I would shade inside of both. So I need to erase these lines. Okay, now we'll do them algebraically. And I'm going to show you a method that you can use no matter what size polynomial you have, a square, a cube, a quartic, fifth power. So first you still want to have it compared to 0 so you can factor it. And I like my x's to be positive coefficients, so I'm going to divide all of this by a -1. So that gives me x squared plus 9x minus 36. And when I divide by a negative, it flips the equality sign, is less than 0. Now I'm going to factor. Factors of 36 that differ by 9 are 3 and 12. And I need the 9 to be a positive, so the 12 would be a positive and the 3 a negative. So when I find my actual zeros, here I get x is 3, and here I get x is -12. So then, on a number line, -12 is to the left of 3. So -12 is a 0. Left of zeros are negative numbers. Right of 0 are positive numbers. I also had an actual 0 at 3. Left of that 0 are negatives. Right are positives. So this will divide it into 3 sets of factors. A negative times a negative would give me a positive, because here I multiplied my factors. A negative times a positive would give me a negative, and a positive times a positive would give me a positive. And then this states that it is less than 0. The factors less than 0 are negatives, so my negatives occur in between here. So they are between -12 and 3. So -12 is less than x, which is less than 3. All right. On the next one, it is already equal to 0, so I'm ready to factor. The factors of 6 that add up to 5 are 2 and 3. Sum, same sign, so they both get a negative. My actual 0 here is 2, and in this factor it is 3. So then when I make my number line, 2 is to the left of 3. 2 was an actual 0. Left of 2 are negative values. Right of 2 will be our positive factors. 0 at 3. Left of that will be negatives. Right will be positives. So then where my zeros land, I see a negative times a negative gives me a positive. A negative times a positive gives me a negative. And a positive times a positive gives me a positive. And this time, I am looking for the factors less than or equal to 0. Less than, again, fall in between. So my x's are in between 2 and 3. Less than or equal, less than or equal. Last one, this one does not equal 0 yet, so it'd be 2x squared minus x minus 3 greater than 0. And now I can factor 2x and x, 3 and 1. This gives me 3x. This gives me 2x. I need their difference to be a -1. So it needs to be a -3x and a positive 2x. So this one would be the negative and this one would be the positive. So when I solve this one, I get 2x equals 3, divide by 2. X is 3/2. And this one, x is a -1. So then my solution, -1 is to the left of a 3/2. -1 was a 0. Left are negatives. right are positives. 3/2 was a 0. Left are negatives. Right are positives. And again, I have my 3 divisions there. Negative times negative is a positive. Negative times positive is a negative. Positive times positive is a positive. And this time it states greater than 0. Greater than 0 are positives. So my positives landed out here and out here. So my x's are less than -1, or my x's are greater than 3/2. When they land outside of both, you use an or. X is less than -1,